So one of our other things we've got to do is we're going to look at histograms. So once again, it'll be you have your columns like this and you'll have your histograms. But we have to look at it when they use a log scale down here. Now, it's always going to be log 10. And why do we do it? It's because we have too much in our categories. They range, like, it stretches out over too many things. So we log the number to reduce the categories down. So what does that mean? So if you have a look, if you had the number 0.01, that could be written as 10 to the power of -2. That's another way of writing it, okay? Now, then if you have the number 1, that's the same as saying 10 to the power of 0. So instead of, it allows us to condense the data and bring it all in. And when do you use it? Often when, like, say they collected the weights of all the animals, all the species in a zoo. Like, you're going to have like a spider worth, micrograms, and then you've got an elephant way up worth tons in the other scale. So they'd be too far apart if we started at micrograms and go all that. But if we use their log scale, we change their number to a log number, it condenses it in. And we do it like this. So what we're saying is, if you had the number 100, that could be written as 10 squared, couldn't it? Yeah? And if you had the number, say, 1,000 could be written as 10 to the power of 3. Yeah? So it will allow us to condense it, because if you think, if I have 10 to the power of 0, that's 1. So I could scale this out where along the bottom I say, instead of saying 10 to the power, they just say it's a log scale. They'll say log scale down here, and they'll have 0, 1, 2, and 3. So what that means is, if you see log scale and you see 3, it actually means 10 to the power of 3, so that would mean 1,000, yeah? And this one actually means 10 to the 0, which actually means 1, okay? So we can flick it around, but here's down here. So here's an example of what I said. This was the body weight of the animals in a zoo, I believe. And see how it's scaled out, because here's this big 90,000 gram or whatever, kilogram, whatever animal that is. And see how when you do their normal weight, it looks like that. If I use their log scale, it pans out to, the data distributes like this. And then it's a bit more, we can see what's going on. Because we can see where the common, median is with this. So if you looked at this, we could say this is symmetric, isn't it? Yeah? And if you look at this is a percentage histogram. So if I was trying to find the median occurs at 50% of the data, yeah? So if you had a percentage, so if I went along, this was 4, say this is 8, this is, 20, just roughly, yeah? And this one is, say, 25. So if I was going up along to 50% heads in here. So I would say the median occurs somewhere between 10 to the power of 1 and 10 to the power of 2. So what's 10 to the power of 1? Actually 10. And 10 to the power of 2 is 100. So what we say in that zoo, most of the animals, 50%, the median weight for the animals is between 10 and 100 kilos. And that would probably make sense. We'd have lots of animals within that range, yeah? So it is always log 10. We don't change it. Always log 10 for us in. Okay, so if you are asked to find the log of a number, and now we're practicing two significant figures, we still will cover this a bit later. So find the log of find the number whose log is 2.7125. What we're actually saying is that the number is actually 10 to the power of 27125. So if I do that on the calculator here, you can see some animal that has that log number is roughly around 500 and, I'll just round it, 560. Oh no, it said 2 significant figures. So if it says 2 significant figures, what that means is, so I'm going to say it's roughly 516. 2 significant figures means you start counting your figures as soon as you have a non-zero. So 5 is a non-zero and 1 is a non-zero, but I can't leave it as 51, can I? It's actually 510, so I just put a 0 for the rest of the numbers until you reach your decimal point. So there you go. So that would be 2 significant figures. If you had to find, say the person was the animal was 45 kilograms and they wanted the log number, you can see they've just typed in log 1045 and it got a number of, a log number of 1.65. So that's a 45 kilo. Now that makes sense, isn't it? Because you said 10 to the power of 1 is 10. And 10 to the power of 2 is 100. So wouldn't 1.65 be somewhere between 10 and 100, which it is, 45. So that's how you know you're doing the right thing. All right, so let's have a look at some of these questions. We'll go through some questions so you can see what you're going to do. So the histogram shows the distribution of weight of 27 animals. So there they gave me n equals 27. What body weight in kilograms is represented by number 4 on the log scale? So we know that means 10 to the power of 4, which is actually 10,000. Okay, so we've said that there. B, how many of these animals have a weight more than 10,000? So sometimes you've got to look and you've got to go, all right, well 10,000 is a log scale of 10 to the power of 4. So you go down there and we look at this. This is percentage. So I'm going to say that's 8%. So we've got 8%, but it's 8% of 27. So if you want to find 8%, you change it to a decimal and times it by 27. So we get 2.16. All right, so we'll probably say 2 animals there. Then it said the weight of the cat is 3.3. So remember, 10 to the power of 1 is 10. So the log should be less than 1. But remember, 10 to the power of 0 is 1, so somewhere in between there. But you can just type in your calculator. I've shown you there. Log 10, 3.3 kilos, and it ends up being a log scale of 10 to the 5, I'm going to say 2. So that would be sitting like that, 10 to the 5, 2 gives what will give 3. Okay, and then determine the weight in kilogram whose log weight is 3.4. The elephant, write your answer. So if they've got a log weight, that means you just put 10 to the power of 3.4 in your calculator, and you can see the elephant weighs roughly 2,512 kilos. And that would make sense for an elephant, so we're good. All right, the histogram below displays the weight distribution of the 143 birds again. So, of the different species living in a small zoo. So, they're very ranged out. Over here, histogram 2 displays the weight distribution of the 143 birds on a log 10 scale. So, how many of these birds weigh between 10 grams and 100 grams? So remember, if I want a 10, the number 10, how do I do that in a log? It would be 10 to the power of 1, yeah, equals 10. And how do you get 100? 10 to the power of 2 gives 100. So we want to look between the log scale of 1 and 2. So that's between here and here. So this is a frequency and it is asking how many. So I'll say 37, is it? Yeah? So 37 birds weigh between 10 and 100. So if you have to create a log scale, you pop your list into your listen spreadsheets like we did with the histogram. And then what you do is you create in this next to it, you want to create a list of all their weights or whatever you're talking about in a log. So down in this little shadowed bit, just under your label of that column, you press equals and you pick the log 10 button, you write log 10, and then you just put, see how they called their original one weight? So whatever you called your original list, type it in there. It should come up bold, and then you press enter and it fills it in. Then you've got a list of all the log numbers, and then you just create your histogram the same way. So you can practice that as well.